All right, this section 3.13.3 says facts about the F distribution. But really, this is just now, let's do a hypothesis test uh, with ANOVA using the Fisher's F distribution. All right, so, I think the best way just to learn this is maybe to learn it through an example. Um, so, as part of an experiment to see how different types of soil cover would affect slicing tomato production, Marist College students grew tomato plants under different soil cover conditions. Groups of 3 plants each had one of the following treatments: bare soil, commercial ground cover, black plastic, straw, and compost. All plants grew under the same conditions, as were the same variety. Students recorded the weight of tomatoes produced by each of the 15 plants. So you can see we've got 5 categories, and these categories have numerical values, okay, recorded for each one. So, let's proceed with doing an ANOVA hypothesis test. So we want to see maybe if there was any difference in the weight of tomatoes grown under each of these different soil types. Now, again, the ANOVA test isn't going to tell us which was better. We're just going to know if there was any significant difference or not. Okay, so note that this example has 5 categories. Each category has an equal sample size of 3. Okay, the sample sizes don't have to be equal. Okay, but in this example, they are. So since we've got 5 categories and we have a sample size of 3 for each category, that is a total of 15 plants that were grown. So that total of 15 plants, that's our capital N. That's our total sample size, okay, for across all categories. So using a 5% significance level, test the claim that there is no difference in mean yields among the 5 groups. So the null hypothesis is always going to be that all of the means are equal. There's no significant difference. And the null is going to be the original claim. The alternate hypothesis is that at least one of the category means is significantly different. That's the alternate. Now, the first thing you want to do is go ahead and enter the sample data for each category into lists on your Texas Instruments calculator. So list 1 is going to be everything under the bare soil. List 2 is commercial cover. 3 is black plastic. 4 is straw. 5 is compost. So you can see all those values have been entered here into list 1, list 2, list 3, list 4, and list 5. And I've gone ahead and done that here on the emulator. Okay. Now to do an analysis of variance test, you want to go to the ANOVA function. Okay. And after you run the ANOVA function, you're going to have to put the lists in manually. And when you hit enter, it's going to give you the test statistic, the p-value, the degrees of freedom in the numerator, and the degrees of freedom of the denominator. Okay, and then to get the critical value, we will use those degrees of freedom of the numerator and denominator. Okay, you put those in along with the significance level, and it gives you the critical value. All right. Now on the NumWorks calculator, because it does not have an ANOVA function, I created a MyOpenMath problem. So if you're looking at the PDF of this right now, you should be able to click on this link and it'll automatically open a new web browser tab with that function in it. This will also be a clickable link in your homework and on the exam. So you'll have access to this during your homework and during your exam. But this is what it looks like, okay, right here. Now, this was the best that I could do. And so what you do is you just go ahead and type in all of the data, but the data in each column is separated by a comma, right? So if you see 26, 25, 53, 48, 26, 25, 53, 48, right? Comma, 65, 83, comma, 72, 85, comma, 62, 77. Then you hit the enter key, carriage return, 29, 97, 56, 82, and you put commas in between. So 29, 97, comma, 56, 82, comma, right? So you can compare, these data values should look exactly like what you see in that table. Now, I mean, when you do analysis of variance, in a table like this, um, you could have gaps. Okay. So for example, what if a tomato plant that was being grown on black plastic, let's say plant number 2 died. Okay, then you would have a gap here. And so where you have a gap, um, you wouldn't put a number here like in list 3. And here in this ANOVA calculator, you would just leave it a gap and put another comma, right? So this blank space, there's actually no space at all. It's just comma, comma. That's for the dead plant, okay? So if you had gaps or if you had columns of unequal sample size, you would just leave a blank space, okay? But you'd still represent it by putting an extra comma in there, okay? And that's kind of what I've given here as an example on the side. Okay, but our data doesn't have any gaps in it. So this is a lot more straightforward. And then when you click submit, the submit button, then it's going to give you the test statistic. It'll give you the p-value. It'll give you degrees of freedom of the numerator and degrees of freedom of the denominator. All right. So let me show both of those really quick. So here we are with the Texas Instruments. So I'm going to click Stat. I'm going to go to Tests. I'm going to click the up arrow key because it's the last one. And now I need to put list 1, comma, there's a comma button. List 2, comma, list 3, comma, list 4, comma, list 5. Now, since the 5th was the last one, I now hit parentheses, hit enter, right? And there's my test statistic, 4.48098. There's my p-value, 0.02479. Degrees of freedom of the numerator is 4, and degrees of freedom of the denominator is 10. All right. Just in case you're asking, the older Texas Instruments calculator, they does have the ANOVA function. Okay, I'll just show you really quick. Let me quit out of that. Why does it keep doing that? Quit. Stat, tests. Oh, okay, tests. I know what I did. Okay, click up. Sorry, ANOVA is the last one. And you put list 1, list 2, list 3, list 4, list 5. Okay, so it has it. Yeah, so with NumWorks, this is the MyOpenMath. This is what it looks like. So I just finished entering in all this information. And if I click submit, you can see it calculates the test statistic, it calculates the p-value, degrees of freedom of the numerator, degrees of freedom of the denominator. And then you can just leave this open, and if you were to enter in, a new data set, you hit submit again, and now it gives you the test statistic and the p-value for that, right? Okay, let me put that value back in. All right, so submit, and there we go. So you can compare the values are exactly the same. And then, to get the critical value, so let's back out. So on the NumWorks calculator, go to the distributions app. We'll go to Fisher's F. Degrees of freedom of the numerator was 4. Degrees of freedom of the denominator, 10. Next. And we want, oops, sorry. I want the area to the right. Significance level of 5%. Okay, and we get 3.478 for a critical value. Let me scroll up here. 3.478 for a critical value. Okay. Texas Instruments calculator. Go to program. Oops, inverse F was actually the first one here. 0.05 for the significance level. 4, 10, the critical value, 3.478. Okay, same value there. All right. So these are just screenshots, showing the stuff that I just now showed you. And when we put all that together, right, here's our critical value of 3.48, which divides the reject the null on one side to fail to reject on the other. This is actually what the F distribution looks like, with degrees of freedom of the numerator equal to 4, degrees of freedom of the denominator equal to 10. This is exactly what it looks like. The p-value, the test statistic was 4.48, so that's above the critical value. So we're going to reject the null. And, the p-value is smaller than the significance level, so that means we're going to reject the null there too. The null hypothesis was the original claim, and we're rejecting the null. So we're going to say there's sufficient evidence to support rejection of the claim, but there is no difference in the mean yields among the 5 groups with a 95% confidence level. Okay, so that's the end of that example. The next 2 problems are think pair shares, where you get to try this on your own. Let me know if you have any questions.